Okay, now listen, alright? Don't disturb the class because this will be difficult to take in the first time you are hearing it. And this will set the base for almost everything throughout your plus 1 and plus 2. So if you fool around now, you will lose heavy. Alright? So listen, first of all, what does calculus deal with? Right? It deals with instantaneous rate of change. Right? It deals with instantaneous rate of change. So if we talk about certain physical quantities, such as velocity to start with, what is velocity? Yes, it is speed with direction. It is a vector quantity, but essentially it is rate of change of displacement, right? So how do we find speed? For instance, if I were to give you a practical problem, such as I were to say a body traveled from a displacement of 3 meters in 2 seconds. How do I find its velocity? I divide 3 by 2. I take the time interval for which the body has traveled, which is 2, and I divide 3 by it, right? I take total displacement by total time, and I say in that interval speed is 3 by 2 meter per second. Now, let's say that the velocity is not constant. For instance, in the case of an accelerating car, right? In the case of an accelerating car, we would define something like average speed, right? We would define something like average speed. We will take the total distance and divide by the total time. We will say the car has gone from Trivandrum to Kollam, which is roughly 70 kilometers in 1 hour. So we say that it traveled 70 kilometers per hour, right? But if you look at the speedometer of the car, there is a different value that is being shown, not 70 kilometers per hour all the time, right? When you press the accelerator, the speedometer will show a certain value, maybe 40 kilometers per hour, 45 kilometers per hour. It shows, as a matter of fact, an instantaneous value of the speed, right? Or an instantaneous value of the velocity is shown. What instantaneous value means is the velocity at that instant. So this is one explanation of the derivative, right? So in calculus there are two mathematical operations that you have to worry about. One is the derivative and the other is the integral. Have you heard of these terms before? Yes. So the derivative has two particular interpretations. One is the physical interpretation, where it is the rate of change of a quantity at a certain instant, right? Where the derivative is the rate of change of a particular quantity at a certain instant. The mathematical idea of what a derivative is the slope of the graph, right? So the first thing that we will be learning is about slope, all right? And we will go into the physical variant later. Okay, so how many of you learned what slope of a line is in 10? You are all ICSE? CBSE. In CBSE, did you learn what the slope of a line is? You did not. Okay, I will teach you what the slope of a line is, all right? So essentially, if I have a line like this, not like this, hold on. If I have a line like this is the equation, this is a line in the xy plane, right? This is the x-axis and this is the y-axis. This line will have some equation, right? I am calling that equation of a line will generally be of this form: ax plus by plus c is equal to 0, right? But it is possible for us to divide by b on both sides, right? So you can get y is equal to minus a by b, x minus c by a. right? C by B, sorry. Right? So it is possible to get a line in a form like this, y equal to mx plus c, right? So instead of minus c by b, I have substituted c, and instead of minus a by b, I have substituted m. So y equal to mx plus c is a generalized form of the equation of a line, right? I can make the coefficient of y to be 1 without loss of generality, correct? Do you know what that means, without loss of generality? It means that ax plus by plus c equal to 0 will represent every possible line in that plane, right? If I draw a line like this, like this, like this, my word, like this, yeah, however I draw the line, right, the equation of that line will be of the form ax plus by plus c equal to 0, right? There is no other way in which you can dream up an equation of a line which is not in this format, correct? Now I divide both sides of the equation by b, I will get this, y equal to mx plus c, right, of this form. I have substituted minus a by b, whatever it is, for m, right? So without loss of generality, I will get the equation of a line to be y equal to mx plus c, and that equation can represent every single line drawn in the plane, all right? Out of those in this particular equation, m is called the slope of the line, right? So what that essentially means is that the angle made by the positive direction of the x-axis, the angle made by the line with the positive direction of the x-axis is the it's not the slope, tan of that angle is the slope, right? If the angle made by the line with the positive direction of the x-axis is theta, then tan theta is equal to m, right? So how do we get this? How do we get this? So this line has an expression y equal to mx. C is 0 here. Why? Because this line passes through the origin, correct? This line passes through the origin. That means y equal to 0, x equal to 0 is a point that satisfies this line, right? Right? The origin has to be a part of this line. So in this expression, therefore, c must be equal to 0 for this particular line, right? Not for every line, for this particular line. And here, to find the tan of this angle, right, if I were to take a distance x naught like this, right, if I were to move by a distance x naught along the x-axis, what would be the relevant displacement along the y-axis? Y equal to mx is the equation that satisfies this line. Yeah, right? So here this point is going to be x naught comma mx naught, right? Correct? Are you following so far? Anybody lost? No? You've not understood. So we want to find a point that is on this line. We want to find a point that is on this line at a distance of x naught from the x-axis, right? So for a distance of x naught along the x-axis, the corresponding y or the height is going to be mx naught, because the equation that satisfies this line is y equal to mx, right? So this is going to be mx naught, and this is going to be x naught. So what is going to be the tan of that angle? Opposite side by adjacent side, mx naught by x naught, which is m, right? So if I give you a general equation of a line and I say y equal to mx, right? If I say y equal to mx, the slope of that line is m, or the tan of the angle made with the positive direction of the x-axis is m, right? You have to remember it is made with the positive direction of the x-axis. That is correct. So what about if I were to say, give you an equation like this, y equal to minus x? Can you draw this graph in your paper? I mean in your book? Can you draw this function in your group, in your paper? Huh? Done. Show me. Yes. Can you draw y equal to minus x in your book? So that you have only drawn half of it. So for positive values of x, there will be values of y as well? What on earth is that? What? Yeah, sure. But I will wake you up to ask you questions occasionally. Draw it. That is wrong. Because you have drawn not at the origin. Yes. Okay. There is something that I like to call applying brute force, right? When we are stuck, we will follow a rigorous procedure to find out the graph of y equal to minus x, right? For that, let us start by drawing the x-axis and the y-axis, okay? In engineering, brute force is something else. Brute force is something else. But in this particular class, when I say brute force, it means we are going to do it in the most precise manner, okay? So here, this is 1, 2, 3, 4, 5, minus 1, minus 2, minus 3, minus 4, minus 5, minus 1, minus 2, minus 3, minus 4, minus 5, 1, 2, 3, 4, and 5. So for y equal to minus x, when x equal to 2, first of all, you know that this is the equation of a straight line, right? You know that y equal to mx is the equation of the straight line simply because it is linear, right? So for this expression, when y equal to minus 1, no, when x equal to 1, y equal to minus 1, right? When x equal to 2, y equal to minus 2. When x equal to minus 1, y equal to 1. And when x equal to minus 2, y equal to 2, right? Correct? So, I will have to change the points. Right? This will be the equation of the line, and it will pass through. I mean, this will be the graph, and it will pass through these relevant points. It is going to be a straight line, right? So, what exactly is the angle made with the positive direction of the x-axis here? What is the angle made with the positive direction of the x-axis? What? No, not negative 45. 135. The angle made with the positive direction of the x-axis, it can also be taken negative 45. It's fine. But we generally say that the angle made with the positive direction of the x-axis is 135 degrees, right? And tan 135 is how much? What is tan 135? Negative 1, right? So you see why you have been taught sine, cos, tan of angle is greater than 90, right? Because tan 135 is minus 1, and this equation also follows the general law that y equal to mx plus c, right? Where C is equal to 0 in this particular case. Now what happens if C is not equal to 0? The line does not pass through the origin. Instead, for x is equal to 0, y has a value of C, right? For x is equal to 0, for this expression, have you taken this down so far? Did you take this down? So take this down first. This is just y equal to mx, right? Every line will be represented by some linear equation, right? Ax plus by plus c equal to 0 for some values of a, b and c will represent every possible line in the plane, right? If I draw an arbitrary line like this, there is some equation of this form that represents that line. But I can make the coefficient of y 1 by dividing both sides by b, right? So this becomes of the form y equal to mx plus c. And y in the coefficient 1, y in the coefficient 1. It is not, this can be 2x plus 2y plus something equal to 0. But I can make the coefficient of y1 and write it in this form, y equal to 3x plus 4, y equal to 3x minus 4, y equal to x by 2 plus something, like that. But the coefficient of y will be 1. So this does not lose any generality. You understand? Okay. Did you write this down? What is it? So, E point എന്ന് പറയുന്നത് has an x coordinate of x naught, right? If this point is x naught like this, what is this? The point is x naught comma x naught into m, right? E line passes through the origin. It is y equal to mx is the formula of this line, right? Is the equation of this line. So any point is going to be of the form x naught comma mx naught. Y equal to mx, right? Every point that satisfies this equation is going to be x comma y. When x is x naught, y is going to be mx naught, because that is the equation of the line. M is the slope of the line, yes. So every line passing through the origin will be of the form y equal to mx, right? If it is of the form y equal to mx, then m is the slope because of this. Y-intercept. Okay. So listen, how do we know that this angle, for instance, is 45? No, we know that this angle is 45 because, or the tan of this angle is -1. The tan of this angle, so the tan of this angle is -1. We know that because if we move like this by x naught units, right? This height by minus x naught, I mean, because we are moving in the opposite direction, right? This is going to be y, right? Which is going to be equal to minus of minus x naught, which is x naught. Or the tan is going to be -1. You understand? Yes, we are finding what the tan of the angle is first, right? Yes, then we are finding the angle made with the positive direction of the x-axis. Okay. Okay. Now I want you to handle for the generalized equation. We will do some examples first. What? Yeah, okay, okay. Yeah, I remember. For the generalized expression y equal to mx plus c, if I substitute x equal to 0, am I going to get y equal to 0? What if I am going to get that y is equal to c, right? This line y equal to mx plus c, where c not equal to 0, does not pass through the origin, right? It passes through the points x equal to 0, y equal to c, like this, right? This c is called the y-intercept of the line, right? This is the point where the line cuts the y-axis, right? The y-intercept is the point where the line cuts the y-axis, and the point is 0 comma c, right? Okay, now can you find me the slope of this line? I have told you it is m, right? Can you prove it though? Can you prove that the slope of this line is m? That tan of the angle made with the positive direction of the x-axis is in fact m, right? So if I say just y equal to mx, you can solve now? Yes? If I say just y equal to mx, you can prove that the tan of the angle made with the positive direction of the x-axis is m. But now I have added constant term c. Hmm? No, x is varying, it's a line. So what we are essentially doing when we are drawing a line is we are collecting all the points which satisfy this equation. For example, if I say y equal to x plus 1, the point 0 comma 0 does not satisfy this equation, right? But certain points do satisfy this equation. The solutions of this equation are a certain set of points, right? For example, the point 0 comma 1 or the point 1 comma 2, these points satisfy this equation, right? So I am drawing the locus of all of the solutions to this equation, right? I am putting together all the points which satisfy this equation on a graph, and it is going to appear to be a straight line. Do you understand what a straight line actually means? Was that clear earlier? That was clear earlier, right? So can you prove that it is equal to m? Could I have some water? Thank you. So y is a variable. Y is a variable which represents the displacement from the x-axis. You know that when you have a graph, you can take a particular point such as 3 comma 2, the 4 comma 5. So there is something called ordinate and abscissa, right? Y is the ordinate. Y is the ordinate. No, no, no. If c not equal to 0, this would not be a point. This would not satisfy. For x equal to 0, y equal to c. Yes. Yes? Hmm? What? No, you have to find the slope. The positive direction of the x-axis. Y equal to, so I have proven to you that y equal to mx has a slope of m, right, with the positive direction of the x-axis. Now I have generalized that equation to y equal to mx plus c where c not equal to 0, right? So the line, the equation of the line is different. So I want you to prove that the slope is still m. So this is not y equal to mx plus c. This is not a y equal to mx plus c. It's passing through the origin. This is passing through the origin. It's y equal to mx. So in the general, you know what general expression for line is? So general expression for line means that when I write y equal to mx plus c, right? If I draw any line on this board like this, I determine my origin, I determine my x-axis, y-axis, and let's say I draw a line like this, right? So this line will have some value of m and some value of c, right? For some value of m comma c, I can find an equation like this, which represents this line, right? When I reduce the expression of this line to this form, it is possible to represent it to that form, right? Because this is a general expression. I can represent it in this form. When I do that, m will be the slope. Surely m will be slope. That's what I asked you to do. No. So for a certain x, this will be mx naught plus c. For some value of x naught, it will be 0. For some value of x naught, it will be 0. For every x, it will not be 0. You understand? Hmm? What? Hmm. Yeah, this angle, the tan. It's possible. This angle tan, this angle tan. To draw a line like this angle tan. They're all the same, right? Because it's a straight line. Eh? Oh. Okay. So listen. We want to find the tan of this angle, right? We want to find the tan of this angle. So we draw a line parallel to this like this, parallel to the x-axis on the y-intercept, right? Let let this distance be x and this distance be y, right? Then the point is of the form x comma y, right? X comma y. So what is y? Y is always going to be mx plus c, right? So we write this as x comma mx plus c. Any arbitrary point on this line is of the form date. Any arbitrary point on this line is of the form x comma mx plus c, right? Arbitrary means representative of everything, right? If I take any point on this line, it will be of the form x comma mx plus c, right? So this point is x comma mx plus c. What is this height, by the way, along the y-axis? That's not y, that's c, right? This is c. Now the tan of this angle, which is the same as this, yes, which is going to be this by this, right? So for this triangle, the opposite side is going to be y minus c. Are you following? You followed. How many of you followed? You are unsure? Y. This height from the x-axis is y, right? Height till here is c. So what is this particular height? Y minus c, right? Now y equal to mx plus c, so that height is mx, right? Eh? Yes. Okay. Now, hey, listen. You know how to take slope for a straight line. Now, for certain curves, slope will not be the same at every point, right? For certain curves, slope will vary depending on the point, right? For example, for the curve y equal to x square, so far in your 10th, you have been dealing only with y equal to mx plus c. Even you have not even learned y equal to mx plus c. You just took straight line, right? Now, for a curve like y equal to x square, which is a parabola, the curve will be like this, right? This does not have constant slope everywhere, right? How do you find the slope of a curve at a point? You draw a tangent to the curve at the point, right? You know what a tangent is? Yes. You draw a tangent to the curve at one point and take the tan of that, of the angle made by the positive direction of the x-axis with the tangent, right? You draw a tangent to the point to the curve at a certain point, and you take the angle made by that tangent with the positive direction of x-axis, right? So how exactly do you find that? So there are several ways you can appear. What? The derivative. Yes, there are certain ways that you can do this, right? Let us say we have a curve like this. So if we want to find the slope at this point, one thing we can do is we can take a point here and we can take a point here, right? So I need to draw a better. Yes. Okay. Imagine I want the slope at this point, right? I can take a point here and a point here and then calculate the slope made by the straight line connecting those 2 points, right? I will get a reasonable approximation of the slope at that point, right? If I want a, yes, then I will get an unreasonable approximation, yes. So the closer I take these 2 points, I am going to get a better and better approximation, right? So essentially, if I have a slope like this, right, a curve like this, for a deviation along the x-axis, for a change along the x-axis like this delta x, you know what delta means? Don't talk. You know what delta means? Change in, right? For a change in the x-axis like this, delta x, there will be a corresponding change in the y-axis like this, which is going to be delta y, right? So delta y by delta x is going to be a good approximation of the slope at that point. If I were to take something like delta x is equal to 0.0001, then I will get a reasonable approximation of the slope at that point, right? Now, the exact value of the slope at that point exists, right? It is not an undefined value. There is something called a tangent which can be drawn to the curve, and there is something called an exact value of slope, right? So how do we proceed in order to find it? What we do is we take the limit of delta y by delta x at that point where delta x tends to 0. So you will have, I believe, a set of doubts here, right? You don't. You are wondering what this term is, right? This will be made clear to you in mathematics once you learn right hand limit, left hand limit, limits and continuity, and differentiability. There is a long way to go before you fully understand what this term means, right? But I will give you a working understanding of what that term means. A working understanding, okay? It is a you have a doubt? It is a working understanding, not an exact definition, okay? You know what APGP is? Arithmetic progression, geometric progression, right? Let's say I have, stop talking. Let's say I have a progression like this, 1 by 2, comma, 1 by 2, comma, 1 by 4, comma, 1 by 8, comma, 1 by 16, etc. up to 0. It will become 0 on the infinitieth term, so don't worry about that. So on, right? It is infinitely extending. There are infinite terms. What is the sum of those infinite terms? What does that mean? So what actually means is that the sum of n terms has a certain function, right? The sum of n terms, limit n tends to infinity, is 1, right? Sorry, this is perpendicular. Hold on. 1. So the sum of 2 terms is going to be 3 by 4, right? The sum of 3 terms is going to be this much. The sum of all of these, that is going to be S3. So for Sn, there will be a function, right? Sn limit n tends to infinity is 1. It means, what this essentially means is that if I take a value greater than 1, you will never be able to give me an n for which the sum of n terms gives greater than 1 value. If I say that I want Sm for some m to be 1.5, m does not exist, right? M does not exist. But If I say something like 0.9, their x is some m. If I say Sm is 0.9, their x is some m, for which the sum of m terms is greater than 0.9 but less than 1, right? Their x is some m for which the sum of m terms is greater than 0.9 but less than 1. What is the maximum value I can put on this side for any m? What is the maximum value I can put there for any m? 0.99. That is 1. $0.999? No, I add another 9, it becomes a greater value, which I can plug in there easily, right? Any value less than 1 I take, there is some m for which S of m is greater than that value, right? For 1 it is not defined, you will never reach 1. But for any other value smaller than 1, I can find some m for which it is larger than that, right? So we say that the limit is 1. You understand? So we cannot literally add up to infinite terms. We say that adding to infinite terms is limited by 1, right? The limit is 1. This is a working understanding of what limit is, right? So when we take in this particular expression delta y by delta x tending to 0, we are calculating the limit of delta x tending to 0, right? The limiting value. We are not substituting delta x equal to 0, right? The example that I gave you, the variable was tending to infinity, right? So here it is tending to 0. Okay, I will demonstrate using an example. Let us try to calculate the slope as a function of x for the expression y equal to x. What is the slope here, by the way? What is the slope here? It's right. What is the slope here? So what is the slope? Is 1. You already know, it's a straight line, right? Need some more water. Thank you. Huh? When you have expressions like y equal to x square, y equal to sin x, y equal to cos x, these are not straight lines. Okay. Yes. So, let us say this is the expression y equal to x, right? So I need delta y by delta x, right? I am going to add y to both sides, right? So I am going to add y and subtract y in the numerator, right? I am going to take y plus delta y minus y divided by delta x, right? Any problem? This is still delta y by delta x. Now here y plus delta y is going to be equal to x plus delta x, correct? If this is x and this is y, I move by a small amount delta x, this will move upwards by a small amount delta y, right? So this point y plus delta y and x plus delta x comma y plus delta y satisfies the line, right? So substituting y plus delta y equal to x plus delta x, here I am going to get x plus delta x minus Instead of y, I will substitute x, right? Minus x divided by delta x is going to be the slope of that function, right? By the way, something I forgot to tell you, this quantity, not this one, this quantity, this whole drama we are doing here is called dy by dx. Don't cancel the d's, right? This is an operation called d by dx. This is an operation, the way you do square, right? If you have x square by 2, you cannot cancel the 2 and 2, right? Similarly, y x square by 2, you cannot do this. This is illegal, right? Because the square is an operator, right? Square is an operator. Similarly, here d by dx is an operation that you are doing on y. D by dx of y is limit delta x tends to 0, delta y by delta x. Correct? So this is equal to, or the limit delta x tends to 0 is dy by dx. This becomes equal to cancelling x. X minus x is 0, right? This is going to be equal to delta x by delta x. So if I substitute delta x equal to 0 here, I will get an indeterminate value, right? If I substitute delta x equal to 0 here, I will get an indeterminate value. Do you know the difference between? It is not defined. It is indeterminate. Do you know the difference between not defined and indeterminate? What? It can be any number, right? Essentially, it depends on other circumstances what the value is. It cannot be determined with the present information. That is what indeterminate means. Not defined means that the value is either blowing up to infinity or blowing down to minus infinity. That is what not defined means. But indeterminate means that you don't have sufficient information to determine what the value is. For instance, expressions like this, 0 by 0, infinity by infinity, infinity into 0, these are indeterminate values, right? Have you ever wondered what the dimension of a point is in geometry? 0. And a line segment consists of infinite points. Now any number into 0 should give 0, right? Except an infinite number of points, which is why the length of a line can be anything. If you take any line, it has infinite number of points, and the dimension of each point is 0. But infinity into 0 is indeterminate, so the length of the line can be anything, right? What are you giggling about? Okay. You cannot directly substitute delta x equal to 0 here. But we are doing delta x by delta x for values tending to 0. That is going to be 1. If I take 10 raised to minus 25,000 or 10 raised to minus 27,000, whatever I take, it is 0 followed by 25,000 zeros and then 1. That is 10 raised to minus 27,000, right? Such a small value even will give me a result of 1, right? So the limit of this expression is actually 1. Shut up, right? You are not directly striking it off. You are not directly substituting 0. You are finding the limit. Now we have 5 minutes left. I will let you go now. 3 minutes, fine. I will let you go now, but as homework, don't spend too much time on it. If you get confused, either read up an extra source or just leave the problem. But if you can solve it, try to solve for y equal to 2x plus 3. Find dy by dx. Yes, but formally prove it. Were you able to do this? Were you able to follow so far? Were you able to follow so far? Was it confusing? You are confused. How many of you have not learned this before? So did you find it confusing? You found little bit. Okay. Hmm? Yes. It's one question, man. Do it.